are going to see the short introduction on measurements and instrumentation. First, let us discuss about the contents of measurements and instrumentation. The first one is definition of measurements and instrumentation. Next, we are going to see the terminologies involved, and later on the purpose of a measurement system. And the fourth one is types of measurements, and the fifth one is types of instruments in measurements, and the sixth one is generalized measuring system, and finally application of measurements and instrumentation. First, let us look into the definition of measurements and instrumentation. Measurement. It is a method to obtain the information regarding the physical values of the variable. That is, if we want to measure any physical quantities like mass, volume, etc., the method or the equipments which we are using to measure the particular value is called as measurement. Next, instrumentation. Devices used in the measuring system. That means if you want to measure the mass of a product, then we are using a physical balance. The device which we are going to perform this measurement process is called as instrumentation. Next, let us discuss about the terminologies used in measurements and instrumentation. The first one is the physical quantity. Physical quantity may be a variable such as the pressure, temperature, mass, length, etc. The second one is the data. It is the information obtained from the instrumentation or measurement system as a result of the measurements made of the physical quantities. That is, any physical quantity can be expressed in terms of some notations or units, that is 50 kilograms or 1 liter, like that. That measured value is called as the data. Information. Data that has a calibrated numerical relationship to the physical quantity. For example, if we are going to purchase 50 kilograms of rice, the quantity is called as the information. The rice which we are going to purchase is called as information. Parameter. Physical quantity within the defined numerical limits. We have to set the limits for all the physical quantities. The next one is the purpose of a measurement system. Now, why we are going to use this measurement system? Okay, the input to the measurement system is nothing but a measurand, or it may be from a process which is otherwise called as the true value of the variable. The measurement system may be a sensor or signal conditioning and display unit. That means this measurement system senses the input which is coming from the process, and it performs a certain processes like using the signal conditioning elements like amplifiers, attenuators, or clipper, clamper, modulations, etc., and it produces the output and displays it in any of the digital devices depending upon the requirements. This output may be transmitted to the observer at the terminal end, and this output is called as the measured value of the variable. This output can be directly viewed by the observer, or by using any tracking control he can obtain the output. The next slide is types of measurements. We are having two different types of measurements. One is a direct and another one is an indirect measurement. In direct measurement, we can easily measure the quantity which we are in need to measure, but it is a less accurate measurement. For example, to measure a steel bar. The weight of a steel bar can be directly measured with the help of any physical balance or weighing balance, etc. It is a direct measurement. Next, indirect comparison of measurement. The next one is it is a calibrated system which consists of several devices to convert, process, amplification or filtering and display the output. For example, to measure the force from the strain gauges located in a structure. That means the strain gauges are used to measure only the pressure, but the desired output is the force. So we are in need of a conversion element to convert this pressure into force. So this indirect comparison is nothing but it will produce the desired output by using more number of elements. Next we will discuss about the generalized measuring system. In the generalized measuring system, the measurand or the true value or the input is given to the primary sensing element or a sensor or a transducer. This sensing element will normally sense what is the input given, or it converts the input to the required form, which is processed, it can be processed by the future elements. This output is detected by the signal condition, sent to the signal conditioning element. This signal conditioning element may be an amplifier or it may be an attenuator. If the signal coming from the sensing element is a weak signal, the strength of the signal can be improved by means of an amplifier, or if the signal is more amplified signal, then the strength of the signal can be reduced with the help of the attenuator. Or certain processes like modulation, flipping, clamping, etc. can also be performed in order to obtain the signal in a pure and acceptable form from high distortions. And this signal is transmitted to the data presentation element through the signal processing element. It may be a data transmission element also. The data presentation element may be a visual display unit, or it may be a recorder or a magnetic disc, etc. This data presentation element can be used for monitoring, control and analysis applications. If it is for analysis applications, we can also use the microcontroller, microprocessors or computers, etc. And the output is directly sent to the observer at the terminal end. The output is called as the measured value. Now the sensing element can be a sensor or a transducer. Similarly, the signal conditioning element may be a amplifier, attenuator with gearing arrangements or filters, bridges, etc. And the data presentation element may be a printer, oscilloscope, computer, microprocessor and so on. Next we will discuss about the types of instruments in measurements. There are two types of instruments, active and passive instruments. Active instrument is nothing but the quantity being measured can be simply modulated to an which can be suited to the magnitude of the external power source. The passive instrument, the instrument output is entirely produced by the quantity being measured. That means the active instruments can directly produce the output, whereas the passive instruments can need some other devices to convert this output. The difference between the active and the passive instruments depends upon the level of the measurement resolution. Next we will discuss about the analog instruments. An analog instrument produces an output that varies continuously as the quantity being measured. Example, deflection type of pressure gauge. That is, the output is not constant, it is varying as the time varies. Next we will discuss about the digital instruments. A digital instrument has an output that varies in discrete steps and has only a finite number of values. Example, revolution counter. That is, we have to take the samples at various time instants from the analog waveform, and those values are converted into discrete values, and the instrument which is used to measure these values are called as the digital instruments. Now finally we will look at the application of the measurements and instrumentation. At home we are normally using the thermometers, barometers and watches, etc. And during the road vehicles we are using the speedometer for measuring the speed, and fuel gauges for finding out the level of the fuel, and in industries